This is Mr. Morgan, and I'm going to be going over the rational functions quiz that we took on Friday. If you're using this video to help you do your corrections, make sure you include all of the work that is shown. Do not just write down the answer. So for our first question, we're asked to fill in this model with h, k, and a based on this graph over here. We're going to do this by analyzing where the asymptotes of this graph have moved from the asymptotes of the parent function. Normally, the parent function asymptote crosses through 0, 0. Now it's crossing through this point down here. That point is 1, negative 3. That means we have shifted to the right by 1 and down by 3. All right, remembering our transformations, sorry about that, we now know that h is shifting right and left, and k moves up and down. So we can go in here, and we can say that h is 1, and k is negative 3. All right, to find out a, we're going to have to do a little bit more work. We're going to plug in this h and this k into our model over here, into our function. That means our new function is going to be f of x is equal to a over x minus our h, which is 1, minus 3, which is our k. All right. To figure out a, we're going to have to replace f of x and x with the coordinates of a point from the graph. So we're going to zoom out and go back over here. So we could choose any point in the graph that's easy to see. I'm going to choose this point, because that point crosses the x-axis pretty obviously there. So that point is 2, 0. So go back over here. So at the point 2, 0, we can say that the 0 goes in for the f of x. So 0 equals a over, and the 2 goes in for the x, 2 minus 1 minus 3. That means we've got 0 is equal to a over 1 minus 3, which means a is equal to 3. All right. So we can say a is equal to 3. And now we can, for the function rule, we rewrite this function with all of our variables put in. So f of x is equal to 3 over x minus 1 minus 3. All right, moving on. Number 2 asks us to list the asymptotes and discontinuities of 3x squared minus 17x plus 10 over x squared minus 25. Whenever you're trying to find both asymptotes and discontinuities, the first thing we need to do is look for the horizontal asymptotes. Those are the y equals. So the horizontal asymptotes are done by comparing the degree of the top with the degree of the bottom. The top of this equation is degree 2, and the bottom of this equation is also degree 2. That means that the horizontal asymptote is y equals the ratio of the coefficients. So the first coefficient is 3 over this coefficient, which is an invisible 1. That means that our horizontal asymptote is going to be 3 over 1, or y equals 3. For the vertical asymptote and points of discontinuity, we now need to factor top and bottom, because points of discontinuity look like vertical asymptotes. So, factoring the top and the bottom, we're going to go in, we're going to find A, B, and C for the top. For the top, I'll work in black. For the bottom, I will work in red. So, for the top, A is equal to 3. B is equal to negative 17. And C is equal to 10. Using those numbers, we're going to find our factors. So, 3 times 10 is 30. We're looking for numbers that multiply together to get 30 and add together to get negative 17. Those numbers are negative 15 and negative 2. Multiply together to get positive 30, add together to get negative 17. That means we're going to rewrite the top of this graph as 3x minus 15 and 3x minus 2. All right. Our next step is to find any common factors inside the terms. So 3 and negative 15 have a common factor. So that means we rewrite this part as x minus 5, because we're dividing by 3 for both the factors. 3 divided by 3 is 1. Negative 15 divided by 3 is negative 5. Now we can set both of these. We could set both of these equal to 0 if we were trying to solve this, but right now we're done. This is the top of our equation. For the bottom of our equation, I'll work in red, we need to do the same thing. X squared minus 25, A is equal to 1, B is equal to 0, since there is no x term written down, and C is equal to negative 25. So we are trying to find the factors of negative 25 that add up to 0. Those are negative 5 and 5. Add up to 0, multiply to become negative 25. That means the bottom of our graph, the bottom of our function is going to be x minus 5 and x plus 5. We won't have to cancel out any common denominator or common factors because a was 1. All right. Now we will be able to find the vertical asymptotes and the points of discontinuity. The vertical asymptotes will be anything that makes the bottom 0 but isn't canceled out by a number on top. So, for example, 5 makes x minus 5 0. However, x minus 5 is on top and bottom. It's here and here. So what would normally be a vertical asymptote at x equals 5, we instead have a point of discontinuity. The point of discontinuity is going to be at x equals 5, so the x value of this point is going to be 5, and y equals whatever it would equal if that point of discontinuity were gone. So if we remove x minus 5 over x minus 5 from the fraction, we will have this new fraction, 3x minus 2 over x plus 5. Plug in 5 for x. We've got 10 on the bottom and 13 on top. So we have, our point is 5 and 13 tenths. There's our point of discontinuity. Our vertical asymptote is what's left over, x plus 5. To make x plus 5 equal to 0, you have to make x equal to negative 5. So that's our vertical asymptote, x equal negative 5. All right. This problem we did in class. If Alex takes 3 hours to finish his homework assignment, and Jocelyn takes 2 hours to finish the same assignment, how long will it take them to finish their homework together? Our first step is to understand that in our equation, x will equal the total time. And we need to find out how fast each of them is working. If it takes Alex 3 hours to finish his homework, then he's moving or working at a speed of 1/3 of a homework assignment per hour. So his speed is 1/3. If times the total time it takes them, plus his help from Jocelyn, which will be 1/2, times the time it takes them, equals how many ever homework assignments they're trying to finish? 1. There's our equation. For our solution, we would have to make the top and the bottom have the same, or the left and the right have the same denominator. So we'd need to multiply the left-hand term by 2, so we'd get 2x over 6, plus multiply the right-hand term by 3, so 3x over 6 still equal to 1. That gives us 5x over 6 is equal to 1, or 6 over 5 is equal to x. So there is our solution, and here is our equation.